So, bonjour, good day. We shall start now the sixth step of our presentation of how we can use diagrams and measurements to help make some audit improvement of your compressed air installations, And the first one was very simple. The methods that we use for auditing and also for training, it's the same. We draw diagrams or schema, which is a kind of thing, sketches, maybe you would say. It's something very limited, but we would like the graph. It's a graph, it would be a transport graph, in scientific words coming from the discipline of operations research. What we are rather operations researchers than énergéticiens. We do not build compressors. We try to understand how the thing is designed and how it works and how it is used, and then we measure it. So diagrams and measurements or measures or measurement results. This is our methods. And before I continue with a more complex diagram, and so a more interesting measurement projects, I would like to turn back to our methods, which is to keep something like a reminder of our goals, So in this first point, I will remind that we very often have to be independent. This is something which is for me especially important. Independent from the excellent people who manufacture compressors, from manufacturers of compressors or boilers, and suppliers of energy. Good people, very often our clients. We work for EDF, we work for Air Liquide, we do work for Areva sometimes, and so when we work, we also work for people who produce compressor, a very good compressor. We have orders from, I think, from Compare. Compare is Gardner Denver. They use our services in France very often, and I think from people from Kaiser. We have some orders from Kaiser compressors. So, we are very open to cooperate with them, but we are independent. It is not good to think that the way we write a report or the way we make an offer for audit would be influenced, impacted by the fact that we may have to help selling a compressor when the right thing to do would be to reduce consumptions. This is something we prefer to be independent engineers. We believe that this is what makes us a bit useful. We are able to do something which is reducing in a significant way energy consumptions. Reduce kilowatt hour significantly. When we speak with our best friends and clients, sometimes they explain that the goal of the French policy, or maybe European policy, I don't know if it's European really, is to stabilize energy consumption in France. They say we are not trying to reduce energy consumption, just prevent them from becoming much higher. This is according to one of my friends, the goal which he has been he has received this goal, this as the work order, from his boss, So reducing, of course, sometimes they can reduce a bit more, but reducing energy consumption in all French plants would have a bad consequence for people who supply energy in France. They would have to fire a few thousand people, and it's not so good for them. So this is an important point. We are not only making technique, we also want to be people with deontology. You know, deontology is something we have these kind of ideas. You know, that an engineer does not make only things for money. This is a point. The point that we have is that we shall put attention on pressure. We have already shown that pressure is a criteria. You know, when there are pressure drops, you know, when the pressure goes down, this is a very bad problem because it can stop some of your machines and even cause some accidents. So we shall be very cautious as we analyze our easy diagrams, and as we choose measurement points, we shall always be interested by assessing the situation of pressure drops and pressure stability. The second point, which is important, it's a criteria for many clients, it's water in compressed air. This is called, more generally, compressed air quality. So we have to think that it's not only the question of maintaining a pressure. You know, if you send water in the air, some machine will stop. You know, so these two elements are actually two qualitative requirements. You know, very often pressure is not considered as a term of quality and an element of quality. It is, of course, it is the first and the most important. But water consumption and maybe oil, you know, well, we shall concentrate in these easy courses that we make on videos, you know, on short videos. We shall concentrate on the most general problem: water, liquid water. Liquid water is a problem. Ice water is worst, you know. Solid water, which is ice, is tapping your pipes. It's very bad also. And the third point, the third criteria is energy. We shall not forget to analyze our diagrams and to design our measurement projects according to some of these criteria, you know, with some priorities, you know, and we may of course have more criteria given by specific clients. You know, the noise is sometimes used, you know, but very few. Even if compressors are very often quite noisy, if they may be a risk of fire, they may cause a risk of fire. These are not very often the request of our clients. You know, we work on these three elements, plus the wish of outsourcing for or changing from contractor, or taking again internally the operation of compressor. These are the most frequent requests that we have from clients. So now I have introduced these deontological aspects and also our goals, and I will present you a more complete scheme. So this is presentation. This is always 6. This is the second page of 6. And what shall we say? We have 3 usages, which we have already introduced. Bag filters. They need dry air and sufficient pressure, but not so much pressure and not a very dry air, you know, simply no liquid water and no ice. We had also cylinders. They would need a bit more pressure. Very often cylinders are the first components which are blocked by a lack of pressure, and they really dislike liquid water. But normally it's possible to have a local treatment to remove liquid water if there is dysfunction of a dryer or no dryer. And then valves, regulation valves. They don't need pressure, so they are very different from the rest, but they do need a very good air quality, no dust, no oil, no liquid oil, and no liquid water. Then we have here, we have our 3 compressors. And to make things a bit more concrete, it's so lubricated screw compressors, LS. It's not a special mark, you know. I hope that no compressor is called LS. Maybe some compare might be something like that, you know, but it means lubricated screw compressors. Excuse me, it's difficult to say lubricated. It's something which is not good for a French mouth. And then we shall decide to have some kind of drying of air, you know, because one of our goals is to take into account energy matters. So the idea that I will have is to have here, I put it this way on my schema, on my diagram, a frigorific dryer. And then this frigorific dryer receives from a humid air collector probably, but we are not very much interested in the way it's done, air, and it gives it to the pipework. There may be still some measurements of flow, you know, fixed measurements of flow, and we go to each of the final usages. Now, what is interesting in this thing, you know, we have introduced here a frigorific dryer. Normally, if you measure here, dew point under pressure, we call that pressure dew point, you should measure +1 Celsius to +5 Celsius. This is what you measure usually. We are not going to analyze very precisely how it works, but we shall, well, the content, the way it functions inside the frigorific dryer is not important. What we shall see is that the biggest difference between the first diagram and this one is that we have chosen a dryer which removes some water, but not all the water, of course. And especially the dew point is superior to 0. Otherwise, you would get ice inside the frigorific dryer, and then no air would go through. It would make a tap, you know. So we are going to check how this first improvement or specification, you know, we discover some white parts of the map, you know, like in the 16th century when the French were traveling in Canada, and we shall try to see how it interferes with the 3 criteria that we have defined. So you see how this type of training might be run, you know, and might be customized to your own installation if you wish, because of course this is usages which are a bit arbitrary. So this was lesson 6. You will have now the 7th lesson with the same diagram and more details. Thank you.